Okay, so this quiz covers 4.1 to 4.3. 4.1 is about our related rates. I am going to give you one that has pretty much been set up for you, and then I'm going to give you one where you have to set it up. And I'm going to do a basic kind of, probably a triangle sort of one. I'm not going to do anything spectacular. Let's take a look at our first one here. How do we know it's set up? Because they've given us the rates, they've given us the equations, and they told us what to find. So we didn't even have to draw a picture for the first one. It's set up for you. Let's do it. Okay. So we know that dy dt equals 2x dx dt. Okay. dy dt is 2x dx dt. Now let's take this stuff, let's plop it in. Okay. So dy dt is going to equal 2 times 1 times 4. So basically, it's going to be 8. So the first one's nice. It's just a standard. Do the derivative. Don't forget to put the dx dt, dy dt onto the problem. Plop the stuff in. You're done. Now, 2 can be that easy if we set it up. So that's the problem. Okay. So first, for number 2, let's read it. It says a helicopter rising straight up at a rate of 25 feet per second. You start running directly under the helicopter at a rate of 10 feet per second. Find the rate of change of the distance between you and the helicopter after 5 seconds. So we're going to draw a little picture because remember, this is a dreads problem. And so here's the helicopter. We're going to call its height y. We're going to call the the distance you have run as x. Now you can call those variables anything you want. You know, it doesn't matter. I like, if it's going in the x direction, I usually do x. It helps my brain. Okay. And then the distance between them, I'm going to label as z. Okay. Now let's think about what we know. We know that the change in the height of the helicopter is 25 feet per second. So that's y. And it's getting higher, so that y is getting bigger. So we know dy dt is a positive 25 feet per second. So that's the first thing we know. Let's think about what else we know. We also know that you are running away from the helicopter, so your distance from the helicopter is x. So dx dt is a positive 10 feet per second. Okay. We want to know how the distance between you and the helicopter is changing. So we want to know what is dz dt. Now they also told us that we are looking at when the time is 5 seconds. So if you remember your basic kind of equations for distance equals rate times time. So our distance x, I've gone 5 seconds at a rate of 10 feet per second. I have gone 50 feet. So I know that x is 50. Now let's think about the helicopter. The helicopter went for 5 seconds at a rate of 25 feet per second. Distance equals rate times time. If you multiply those, the y is 125. And then because it's a right triangle, if I do the Pythagorean theorem, I'm just going to go to the nearest tenth. It's 134.6 at that precise moment. That's the distance between you and the helicopter. Okay, just doing Pythagorean theorem with 50 and 125. So now we got a lot of information. What is the equation that relates these sides of our triangle? Yes. Yeah, we have the equation x squared plus y squared equals z squared. Now, you're going to get used to the answer, hopefully, for the derivative, implicit differentiation for that problem. It's always going to end up being the same thing. It's going to be 2x dx dt plus 2y dy dt equals 2z dz dt. So that always happens for a Pythagorean theorem problem. Okay, so 2x dx dt plus 2y dy dt equals 2z dz dt. So we have everything we need now to plop into our formula. So let's plop the stuff in. Okay, so x was a distance of 50. The rate was 10. Y was a distance of 125. The rate was 25. Z is 134.6. I don't know dz dt. So you'll notice that our only missing thing is the thing we were looking for, dz dt. Now, if you add up all the junk here, if you add all this up, following an order of operations, all that stuff, you get 7,250. And then if you multiply 2 times 134.6, you get 269.2. And then how are we going to get rid of that 269.2? We're just going to divide it off. And then I rounded to the nearest whole number just because otherwise it was to the nearest tenth was a 0. So it worked out pretty nice that this ended up being 27 feet per second. 27 feet per second. You should expect that that distance that rate should be a little bit quicker than the other two sides, just like the legs are in our right triangle. So expect for our 4.1, our related rate problems, to have one that's kind of been set up for you and one that you'll have to set up. And I'm going to kind of stick with a triangle sort of problem. Okay, everybody good with that? And also remember distance equals rate times time would be helpful. Okay, now let's talk about critical points. Critical points are where the first derivative equals 0 or the first derivative does not exist. So for these next problems on your quiz, just find the first derivative, set it equal to either 0 or think about what would make it blow up, what would make it not work. Now, please look over your derivatives tonight and maybe your flashcards. What are the derivatives of the sine, the cosine, tangent? You know, what are the derivatives of some of your funky stuff? Make sure you remember the quotient rule, the product rule, all those, because it could be any type. Okay. So the first step in all these, we just got to do the derivative. So let's start with number 3. The derivative of that is 12x squared minus 3. We know how to do that derivative. That's not a hard derivative. Now that derivative exists for all real numbers, so there's no problems with it not existing. It's a quadratic, so it exists everywhere. But we do have to worry about where that is equal to 0. So let's just take a moment and remember how to solve that. If it was like 12x squared plus something equals 0, your quadratic formula is always a way to go if it's not factorable. Know your quadratic formula, hint, hint. Okay, so that's that negative b plus or minus the square root of b squared minus 4ac over 2a. You will have to know that tomorrow because I just did the quiz key and that's on there. There is a problem where you have to do that. That being said, this one you don't have to. If you take the 3 to the other side and divide off the 12, we can just do the square root of 1/4. Another hint, please make sure when you take a square root of anything and you have inflicted the square roots, you have to put a plus or minus sign or you're missing half of your stuff. So the square root of 1/4 to square root of fraction, just square root at the top, square root at the bottom. Both of those are nice, perfect squares. So we get that our critical points are plus and minus 1/2. Okay, so that is number 3. Now let's just keep doing this. Please make sure that you do any rewrites necessary. So I would always make a square root into a 1/2 power, just like I've told you before. Before you do any derivatives, make sure you do any rewrites that make the derivative nicer. And so if I take the derivative of that, power drops down in front, power goes down by 1, power drops down in front, power goes down by 1. Now that's our derivative, okay? And so let's talk about where the critical points happen. So the critical points happen in 2 places for this one. This is really 2 over the square root of x minus 2x equals 0. Now, what would mess up that equation if I plugged in what number? If our denominator equals 0. So the square root of x is not allowed to equal 0. If it has a negative exponent, it can't be 0. So you can just set the inside equal to 0. So we know one critical point happens at 0. Now let's actually practice solving this a little bit further. I would suggest multiplying through by the square root so you don't have a fraction anymore. Okay, so we get 2 minus 2. Now let's think about this. The x to the first is 2 halves plus 1 half is 3 halves. So I'm going to write that as x to the 3 halves. And then I'm going to solve it. I'm going to move the 2 over. It's going to become a negative 2. I'm going to divide by negative 2. And what's going to get rid of a 3 halves power? Well, that's going to be a 2/3 power. And 1 to anything is always just 1. That's great because then that means the x is equal to 1. So we have critical points when x equals 1 and x equals 0. So we have 2 critical points for that one. 1 because it equals 0 when x is 1, and 1 value of 0 because it messes it up. So don't forget, we have to be aware of what messes it up. For number 5, please put, we're only looking for critical points on the intervals from 0 to 2 pi. We're only going to look for the trig function ones. We're going to just stick with values between 0 and 2 pi. So unit circle values. Okay, so just add that little piece of information on for number 5. Are we good with 3 and 4 so far? Okay, let's look at number 5. Trig functions. Do you remember what the derivative of a tangent is? Secant squared. So y prime equals secant squared. Now, let's just for a moment think about where a secant equals 0. The secant graph I'm going to draw you a very poor rendition, but you'll get it. Is it equal to 0? Nope, it's not. Secant isn't equal to 0. Cosecant is never equal to 0. They go up above 1 and down below 1 because they're kind of like the flip. They're the reciprocal of our sine and cosine. So sine and cosine have lots of spots where they're equal to 0. Secant doesn't, but it does have spots where it's undefined. This is an undefined spot. That is wherever the cosine equals 0. So this can be flipped to, it's not equal to 0, but where is the secant? Undefined. Well, that happens where the cosine equals 0. So, because the cosine graph looks like this. So, and I'll go all the way actually to here. Yeah. So between 0 and 2 pi, the cosine equals 0 in 2 spots, pi and 2 pi. So our answers will be, is it pi and 2 pi? Or is it pi over 2 and 3 pi over 2? Just a sec. Cosine of pi. That's pi over 2. Cosine of pi over 2. Yeah, I'm sorry. So my labeling sucks really bad. This is pi over 2. This is pi. I am. This is 3 pi over 2. There is one. I will tell you for the quiz. No. Just look at the unit circle and just review your sine and cosine values. So, no, but so for tomorrow's quiz, just look over your first quadrant, the unit circle. It's one of those two.
Okay, that makes it much easier. Because those are a lot easier to remember.
Yeah, so tomorrow make sure you know your sines and cosines in the first quadrant, and that will push you in the right direction for these. Okay, so the answer for this one, the critical points are pi over 2 and 3 pi over 2. We did not, we're going to do one tomorrow that's related to the sine and the cosine, so just look over your unit circle values for the sine and the cosine. Okay. Let's take a look now at number 6. Do a rewrite first. Yeah. Huh? What equals 0? What are we doing?
Doesn't this equal out to 0 always?
This one? No, I'll show you. Oh, you have to throw in that x to the negative 2. Okay, so we're going to take the derivative. That's going to be 1 minus x to the negative 2. So that's really 1 minus 1 over x squared equals 0 is what you're looking for. Now, what messes that up? It can't equal 0. So a critical point does occur at 0 because of this fraction right here. Any negative exponent is implying division, and we're not allowed to divide by 0. Okay, now let's solve this. Now we're going to solve that by multiplying everything by x squared so that I don't have a fraction anymore. Always multiply through by the least common denominator, and then you don't have to worry about fractions. But remember, that denominator cannot equal 0. And so we get x squared minus 1 equals 0. So x is plus or minus 1. So we have critical points when x is 0 and also at plus or minus 1. So that kind of gives you some information about your the critical number ones. You're just finding the derivative, setting it equal to 0. Don't forget to include the values that mess it up. And that's just usually fractions aren't allowed to have a denominator of 0. Okay, so then on the quiz, we also have 2 that are find the absolute maximum over a specified interval. Okay, so let's do 7 and 8. So the steps that you're always going to take for this is you're always going to find the first derivative. You're going to plug in the critical numbers. That's why critical points came first. You're going to plug in critical points and the end points into the function. And then you're going to label maxes and mins. So that's kind of the 3 steps that I would take every time I do these problems. So these ones, you'll like these ones. These ones are pretty straightforward. So first step, find the derivative. So the derivative of this is 4 minus 2x. Once you find the derivative, you have to do the critical numbers just like we did in the problems that came right before this. What are the critical numbers? Well, this one only has a critical number where 4 minus 2x equals 0. There's no fractions, there's no negative exponents, there's nothing that messes it up. And you get 4 equals 2x, so x is 2. Now you always have to ask yourself, self, is 2 in there? Is 2 in that interval? If it is a critical number that is not in that interval, you don't get to use it because they're only asking for values within that interval. Is 2 between 0 and 5? Sure it is. So what I do then is I list my endpoints, because we always have to test those, and I list the critical numbers that are in that interval and only the ones in that interval. So if there's a number that is not in that interval, throw it out. You are always looking for the size of it in the original function. So at this point, you'll see I said to plug it into the original f of x. If you plug 0 into the original function, so I'm going to plug 0 into here, I get 12. Earlier I plugged in 5 and I got 7. And then I plugged in 2 and I got 16. So I'm just plugging those into the original function, okay? Because I need to know what's the biggest, what's the smallest. And then I'm going to label the biggest as the maximum. I'm going to label the smallest as the minimum. That's it. So those ones are nice. Those ones are pretty darn good. I like those. Now, you have to be a little bit careful for ones like number 8. Now, you might recognize that problem. We already did that one earlier. We found that the derivative from, this was number 6, we found the derivative was 1 minus x to the negative 2, and we found that there were critical points of plus or minus 1 and 0. So we have already done this problem, so I'm not going to take the time to do with that part again.
Silence is an answer.
No, I don't know. I don't believe so, but I am actually planning on just switching one out that's gross, and so I'll just switch it so it does that. Yeah, I'll do that. So yeah, okay. There's one that was so gross, I'm like, ugh. Okay, yes. So I'll do that. I'll switch it out. Anyway, so let's look at our critical numbers. Is 1 in that interval between 0.2 and 4? Yes, okay. So we get to use 1. Is negative 1 in that interval between 0.2 and 4? No. Is 0 in that interval from 0.2 to 4? No. But we always have to plug in our endpoints. So the critical numbers we found are limited to the ones that are in the interval. Okay? Okay. Earlier, I plugged in 1 and I got 2. Now you're plugging that into here because you get 1 plus 1 over 1. You're plugging it into the original. And then I plugged in 0.2 and I got 5.2. And then I plugged in 4 and I got 4.25. So those are the values I got when I plugged them into the original. And then I'm just going to label the highest is our max over that interval. The lowest is our min in that interval. So these ones, they're not so bad, you know. Okay. And then let's take a look at number 9. Number 9 is about differentials. They're asking us to find dy. So the first thing you're going to do is just do the derivative and write it as dy dx. Instead of y prime, you want to see that dy dx. Okay. So dy dx is going to be 12x cubed plus 2x squared minus 2. Did I do that right? Oh, yes, I'm sorry. It would be 2x. I knew something was weird. Okay. And that's our derivative. Put that in parentheses. Cross multiply the dx over. and we just found dy. So dy, our differential, is 12x cubed plus 2x minus 2 dx. So part A is just a derivative, and then you scooch the dx to the other side. So it's very nice. It's nothing fancy or funky. That's what part A is. What's great about part B is you did the hard work in step A. B, you just plug in the numbers, okay? So dy would equal, where the x is sitting, if we plug in 2, and I'm plugging 2 into this entire thing, I ended up getting 98. And then dx, they said, was 0.1. And so dy, we just multiply those things, and we get 9.8. Okay, so you just plug your x value into here, you plug your dx value right there, and that is your dy value that corresponds with those particular x's and dx's. That's it. So those are nice. And then finally, we have a linearization one, number 10. So the formula you want to have memorized for tomorrow is that L of x is f of a minus f prime of a times x minus a. So that's your formula. Get that into your brain. That's the formula you want to have memorized. Okay, so let's do a little bit of thinking here. F of x is a fraction, so rewrite it with a negative exponent. So that we can do that rewrite, so that we can do our derivative. So the derivative is negative x to the negative 2. You can also write that as negative 1 over x squared. But you can leave it the other way. I don't care. It doesn't matter. Okay. When I'm doing these, this is what I do. I find those values next. So what is f of a? I'm going to plug in 2 into my original. So it's just 1/2. So that's the next thing I like to find. Okay. Next thing I find is what is f prime at a, or f prime of 2, and that's negative 1/4. Because they go into our formulas. Here's my f of a. Here's my f prime of a. So I do the derivative, then I stick a into the original, that's f of a. I stick a into my derivative, that's f prime of a. Now let's plug everything into our formula, okay? So L of x is f of a, 1/2, minus negative 1/4 times x minus 2. Now let's analyze how I got that. F of a was just the function when you plug in 2, 1/2. F prime of a is the function in the first derivative, negative 1/4, right here. And then our a is 2, so just put a 2 there. And then let's pretty this up a little, and then we're done. We get 1/2 plus x. 3 negatives make a negative, so that would be not minus 1/2. And so, you know, I just distributed, and I got x. We're done. That's our answer. Okay. No, no, it isn't. I'm sorry. There, I made the positive, but I didn't take the 1/4 there. That's a 1/4 x. Sorry, I forgot. There's a 1/4 that has to go. So there's a 1/4 x. I put the plus and was all excited about that, and then forgot everything else. So that is your quiz. That's what it's going to look like. It's going to be 10 problems plus a few little bonus options. So there you go. Okay.